Good morning, everyone. My talk is about our group newly developed the early update precise orbit and for the core constellation. This work was done by Hong Yang and Xiaolong, my two PhD students. And my talk about 4 parts. Firstly is overview of ultra-rapid products our center developed. Second is short introduction for updation partner software for developing these products. Third is result. As we know, we start to provide GPS and GLONASS ultra-rapid products for edges in 2012. And we start to provide code constellation product for the HMAS since 2013. And in January of 2016, we published the 3 hours update product for constellation orbit in RGS Data Center at Ohio University. And this year, May, a newly developed 1 hour update product and also published in RGS Data Center at Ohio University. This product include orbit clock and ERP parameters. And a delay is 30 minutes. And the update is 1 hour. In order to make this product, we need to update partner software. As we know, we do a post-batch processing for edges, another center. We process a batch data and get best process results. But we need to consume a lot of time. In order to make better result for real-time application, we need to update our software for structure. Firstly, we go to real-time filtering function. After that, but we cannot run very smoothly because we cannot get enough data for real-time processing. So we changed a little for the fast square batch processing. This means we divided a long arc into several small arcs, and one by one we deal with it. So the fast square batch processing, it can get a scene. Almost the same product with the post-batch processing, but it consumes less time. And we need a strong constraint between every arc. For real-time filtering, we can observe the dynamic model's error by the loose constraint parameters between every epoch, and also can reduce the weight over previous observations by loose parameters constraint. Now, for POD processing, the most important thing is to transfer the initial state vector to from the beginning to the end of the arc, but for the beginning of a new arc. So also we had a deal with can change from epoch or the batch, small batch and big batch processing for Panda update the software. But for all the updates orbit dimension published, we just divide a long arc 36 hours non-arc to two parts. First arc is 33, and the second is 3 hours. And a delay is 30 minutes. The first 20 minutes is just waiting for data. So you know that we are 15 minutes the data available for RGS mostly. And for processing is 10 minutes. But for users, in this processing, we needed only predict for the 1/2 an hour and to 1.5 hours. Compared with the products we generate for users available, real-time users available is from 1/2 and to 1.5 hours. And for 3 hours update orbit is from 2 hours to 5 hours. This part can be used for real time. And for HU, you know that we can get orbits from real time users for 3 hours to 9 hours we needed to predict. And so it is similar with a short batches. This is the model we used in our early update products models. This is the data. You know that Wuhan University hold the RGS data center and also the HMAS data center. So we can get RGS data, MGS data, HMAS data, and batch or network was developed by Wuhan University. And then also COMOC data in China. This is for crustal deformation monitoring data. All this data mostly is can get each 15 minutes. 15 minutes we can get the data, high rate data. In order to test the accuracy, we compared with GPS product with HL final products, and GLONASS with HL final products. Beidou and Galileo products we compared with GBM final orbit. This is not only because GBM is one of the best quality products, but also if we compare with Wuhan final orbit, it's much closer. So consistent, I think we need to compare with GBM final orbit. So for GPS, if only obtained by us, we can find that for real-time users with only updated orbit, we can get 2 centimeters accuracy and jump between each arc. We are about 7 millimeter. But for 3 hours or 6 hours update products, much worse than 1 hour. If we compare with HU, you know, HU is we know there's the best products for everyone can openly get. We can find if we compare with 3 to 9 hours predicted, we can find the accuracy is very similar. But in some arcs, the jump, we can find a jump because the prediction is much longer. So for real-time users, I think this is very important, especially for PP, AR, something like that. For GLONASS, we can also find that 1 hour update product is much better than 2 or 3 hours or 6 hours update product. Anyway, GLONASS product is not good enough, I think, because we didn't use a newly developed model. But the jump is much smaller than always we can get from open access. This is for W2017 satellites. We can find a small jump, and it's about 80 centimeters. But for HSO and MU, we can get average about several centimeters for accuracy. And the jump is about 1 to 2 centimeters. I think this is good for the positioning, PVP positioning, I think, for real-time users. This is for guiding low. We also can get several centimeters with 1 to 2 centimeters jump with 1 hourly update products. All these products we can get from a data center from Wuhan University. It's just the beginning, I think. We needed to become more stable and more accuracy. Newly developed models can be merged into this processing. So, come to outlook. With more real-time data and better data quality control for the stations, we can change to more newly updated products. And new force model for each constellation is partially for GLONASS. And Beta Geo, we developed nearby. After we implied as models, I think all the products can be improved a lot, I think. Of course, if we can use parallel computing, we need to big change, large updation of our software. Now we cannot support parallel computing for the Panda software. Yeah, we hope we can get 15 minutes in the near future products.